All right, so before moving on to the next stuff, I just noticed that although I have been talking about RS latches, and I also told you about, each and every state and so on, I didn't actually walk through it. And although it seems fairly obvious, it's pretty easy, it's kind of obvious and trivial. It may not be for some of you, because perhaps it's the very first time that you are, learning this stuff and so on. So I just thought that watching back my video, the video I made, I thought it was, worth going through this step by step. So I'm just gonna, you know, um, go back a little bit and talk about the RS latch once again. So if you remember from the other lecture, we had this OR with a NOT, so a NOR gate connected here. And here we have the output Q. Down here we have this, which is then connected to the other output, which is Q naught. And over here we'll have this. So here we have the NOT and the other OR gate with NOT, so a NOR gate connected here with the other one. So this is the R reset and this is the S set. And here we have this way here. Okay, so let's walk through this one more time, shall we? So if we just make this table here, so S R, I'm gonna have Q naught and Q. So if I start, and Q here just means the former state, okay? So if I start with something like just 0, 0, 0, then what I'm going to get will be, well, I will start with an output Q, which is 0. Then what I'm going to get is going to be this. Well, no, actually, I just start with 0. Let's just put set to 1, reset to 0, and let's see what we're going to get. So if we start like this, then what do we have? Well, we know that the Q is 0. We know we have the reset, which is set to 0, so 0 here. We know that set is actually set to 1. Okay, so this 0 here, which we got from the former state, is actually here. So what do we get? Well, we get 1 and 0. This is an OR gate, so it gives us 1, but it's a NOT, so it gives us a 0. So we get a 0 here. And this 0 actually goes all the way to here. So now we have 0, 0, so it goes to 0, knotted, and we get a 1. So now we're going to start with a 1 here, because the output changes here. So we got what we're going to get now, as I'm going to go on with this table here, is the following one. If I have the state of 1 here, I have a 1 here, then if we put set to 1, the output of Q component will still be 0, based on the truth table. So basically what's going to happen is that we have 1 and 1, which is 1, not it, and it's 0, so 0 is still going to be here. And therefore, if we have Q to 1, S to 1, reset to 0, Q complement, and Q, so Q is still going to be 1, and Q complement is still going to be the 0. So basically, we got the 0 here, and it stays the same like that. In this case, when we have set as 1, you can basically see that Q is just gonna stay high. So it doesn't matter as long as set is high, reset is low, Q is gonna stay high. So the next question is, what happens if we drop set to 0? So we use this exact same state with everything that is here. So, but we have this set here, which is, 0. So what do we got? Well, 0, 0. So even if we drop this 0, one of those is still gonna be a 1 because of the output feedback, and this is an OR, so the output doesn't change and the result just stays the same. So we're still gonna get 0 and 1. So the latch is still, gonna retain the value that we gave. If we use the same state, except that now what we're going to do is that the S pin that we previously set to 0, we set it to 1, it's just gonna stay the same. You can basically figure it out yourself and going through the circuit. We can do that, but it would be a kind of waste of time, to be fair. So if we can have something like 0, 0, 0, 1. So if you put the set pin back to 1, it's not gonna change. It's gonna be the same. We will have a 1, and we'll still, get a 0. So it's all gonna stay the same. So we will have 0, 1, 1. Then we clear the input again with 0, 0, and nothing is gonna happen. It's gonna stay the same because we got a 0 here again, a 0 here again. So 0 and 1. So once again, nothing changes. So now what happens if we put the reset pin to 1? So we have basically the circuit which is in this state here, and we put the reset pin to 1. This one here. Well, the set pin is 0, the reset pin is 1. So in this case, we'll have 1 and 0. So 1, not it, so we get a 0. And now with a 0, we get 0 here. So we no longer have a 1 here, we have 0, 0. Now 0, 0 is 0, not it, and we get 1. So basically, since the output of this NOR gate just became 0, we updated this one, which turned this one to be 1. So basically, as you can see, Q is now become a 0, and Q naught, which is the opposite, has now become a 1. So we will have a Q complement as 1 and Q as 0. So you can see that it actually changed. And it was like as we flip those two values. Also because now that we have a 1, this one here will go all the way to here, and we will get a 1 and 1, but 1 and 1 we get a 1 in this OR gate, not it, and we still get a 0. So Q goes to 0 now, and it stays there, and Q complement goes to 1, and it stays there, of course. So you can basically see how the timing fits through in this example. So if we go on with this, it's not gonna change because we're still gonna have 0 and 1. So we're still going to have 1 and 0. However, now that we have 0, 0, if you remove the 0 here and we get 0, well, nothing surprising because the state doesn't change because we still have this one input to the NOR gate, which is still gonna give me a 0. So you know this input here is still gonna be a 0, so we get 1 and it's not gonna change. So it's just gonna stay in the state. So well, actually this one should be a 0, sorry about that. So we'll get a 0. And now finally, if we go to 1, 1, then something bad is gonna happen, as you basically know, because I've been talking about this in the former video. So let's suppose that we are basically in this state. Without all this, let me just cancel those. Oh well, maybe I should mess this one up. Let me just redraw it real quick. So let me just put it back real quick. because I just messed up the the draw I made. So this is our other NAR gate. This is R, this is S. Okay, so let's suppose that we are with 1, 0, 0, 1, 1. We were in these states, right? So what's now going to happen is that if we have 1 and we had 1 here, then it's going to be 1 with a naught. It's going to go to 0, and this 0 here is just going to go here. So 0, 1, the output is 1 with naught, so it goes to 0 here, and this 0 here goes to here, so we get 1, 0, and we get a stable state again. But the problem is that it's not valid, because you can basically see that Q and Q naught, they're not the opposite, they're both 0, and this just doesn't make sense. It's just an invalid state. It doesn't make sense because we would have Q complement 0 and Q and 0, but we said that they were going to be the opposite. So the output and the not output. So yeah, this one is just going to be an invalid state. So yeah, this is basically what it does, what NAR S latch does, and how it actually behaves. So yeah, I hope that going slowly, bit by bit, through all the steps actually helps you and clarify your doubts.